This problem states that at t is equal to 0, the switch comes from this position to this position. That means before t was 0, so when t was less than 0, so or we can say at t is equal to 0, because let's write like that. So at t is equal to 0, the circuit was like this, just t is equal to 0 minus, so just before the switch was closed basically. So circuit would be like this one, and the capacitor will be charged up to the supply voltage. So that means this one, 3 farad here, and this is V. So V will be 12 volts. That will be the voltage to at which it is charged. Now when the switch is taken to this position, the circuit becomes something like this, and this is the capacitor which has already 12 volts here, which is V, and 3 farad, 2 ohms, and here it is 4 volt. Now the capacitor will discharge through the resistance, and we have to find the expression of the voltage. Now in this case we have a voltage source here. It has a voltage which is less than the capacitor's voltage. So finally the capacitor will discharge its 12 volts, and the final voltage the capacitor will attain is 4 volts, because once the capacitor cannot store its charge, and it will discharge through the resistance. So V final for the capacitor, I will use a lowercase. So V final, Vf will be 4 volts, and V initial for the capacitor is 12 volts. So the expression is, we have to remember the expression for voltage is V final plus V initial minus V final, lowercase, sorry, times e to the power minus t over RC. So t over RC, here R is the resistance through which it will discharge, and C is of course the capacitance value of the capacitor. So RC here is, RC here is, R is 2 and C is 3, so RC will be 6 seconds, so that's there. And V final is 4 and V initial is 12, so this is 4 plus 12 minus 4 e to the power minus t over 6, so that will be 4 plus 8 e to the power minus t over 6 volts. So that will be the expression of the voltage across the capacitor. This is the way it will discharge. And if we look at this equation, when t is equal to 0, when t is 0, V becomes, this is 4, and this part becomes 1 because t is 0, so e to the power 0 is 1, so 4 plus 8, 12 volts. That is when t is equal to 0. And when t is equal to infinity, this one becomes, this part becomes 0, the whole thing becomes 0, so 8 times 0 is 0, so this will be 4. So that is the final voltage, which is V final. So yeah.